Hello, student. So I hope you are enjoying the lecture so far. And this lecture I am recording as a hands-on lecture for the lecture 2. And you probably have seen this lecture, the AI's bias detection and fairness metric. This is the second lecture of the course. And if you have not gone through this lecture, then you can go through this lecture and then come back to this hands-on tutorial. So what in this hands-on I am taking you through is basically using the Python code written in a Python. Different topic which I mentioned in this AI bias, which was more of a theory. So in this practical, by doing this Python programming and using some data set, I'm going to show you that in the programming way and also visualize it, how it will look like when I say it is biased data or the fairness metric is incorrect and different metrics we have calculated like SPD and other thing. So we will be able to see that how by changing the threshold, how the fairness metric is changing and common kind of fairness metric using some example data. Data also I'm going to create with the Python synthetic data and will show you. Now, this Jupyter notebook, so this is made in a Jupyter notebook, IPYNB file. I will give this description in this file description in the file link in the description. You can download the file, and then what you need to do, you simply need a Google Gmail account. And if you have a Gmail account, then you can simply type uh, colab.research.google.com. I will give you this also in the link description because this is a first lecture. So if you go there, uh, then what you will see that you have this, you will land up this page, not the page because I am already logged in. So you have to log in to this site since I have already logged in. So I have reached here. So you have to log in to this site. Once you log in, you will be at this kind of screen. And then you have to click this file. You can see file and you have to say upload notebook. And then you have to browse in your computer or in your mobile phone. Where is the file? And you have to upload this file. Okay. So I have already uploaded the file and this is the Jupyter notebook. So once you load it, you will see this. Now, I'm not taking you through the how to write a code in a Jupyter notebook. So this is a pre-written code. What is needed is that you are running this code on the Google Cloud and this where the compute system is provided by Google. And you can write a code also, but in this particular text is written in a text file. And then you have the code below. Okay. So in this code, what is that we are going to take some example and we'll take you what is a confusion matrix, what is a group-wise performance comparison, and then statistical parity difference, different kind of biasness we have calculated, and equal opportunity difference. So using the code, I will take you through. So if you see that uh, the first thing which written in the Jupyter notebook is that I am, and if you know the Python, so very basic Python library I'm importing. So in the Jupyter notebook, these libraries are already there in the backend. You don't have to install this library. So I'm importing NumPy library and as an NP, and then Pandas library as PD, which is a pseudonym, and matplotlib because I'm going to do some visualization. So a matplotlib and then this random seed generator I'm doing. So first code, uh, first uh, example is what I'm doing is I'm creating a simple synthetic decision data set. So I'm creating two groups, group A and group B, and where the labels of the group A is y true, and then what model is going to predict is in the variable y underscore prediction, and the score for the AI model running will be there in the score. So values which we have chosen so far is SPD, EOD, and PPT. So in this example, so what you typically need to do, you need to run it, or you can run from here, run all, or run one by one. So I start with this. So it is going to run it. Once running is finished, this rounds, you see the rounding is happening. It will be finishing. Okay. And then one by one, you can run, and then you will see that we have the code, then you can run it. So in this, what has been given that we have created group A, which has approval rate of 52%, and true positive rate of 86%, and PPB of 81%. And similarly, group B, which has taken approval rate of 49%, and TP true positive rate as 72%, and PPB as 79%. So here I'm creating this Python, written a Python program where I have given the group name, what is a label, and what is a prediction. And with this, I have created this simple program where false positive, true positive, what is a true negative, and what is a false negative. So these are the things needed to create a confusion matrix. And if you see that I have created this data, and in you can see the why the true positive small amount of data has been shown. Uh, Prediction is 1, and then score is 0.78. So this is, if you run it, you can see. Now after this, if you run the next file, then you will see uh, the data set, what data set I have created here, where you can see the total is 90, and actual positive is 50, but predicted by the model is 52, and average score is 56. Similarly, for group B, the actual positive is 50, but the predicted rate is 45, and the average score is 54. So this is I have created as an example. So now here I am trying to visualize the score distribution by group A and group B. So in this very simple program has been written. And you can see the model score, which is I am doing distribution by group. And here the model score is there from 0 to 1. And blue color is for group A, and the orange color is for group B, which is showing that how the different group are being models are giving the outcome. Now, if we calculate the confusion matrix of it, so for confusion matrix is what you need is a true positive. So true positive means it was if the model was label was positive, and model has given the outcome as positive. Let's say cat and dog. Okay, so if the image is of cat and model predicted as cat, then it is a true positive. But if model had predicted dog, then it will become negative. So similarly, the true positive, false positive, true negative, and false negative rates are being needed for determining the confusion matrix. So in this, what we see for this particular data set, the true positive for group A is 43, and false positive is 9, and true negative is 31, and false negative is 7. And in total, I have taken as 100. And similarly for group B, it has been taken as 38, 35, and 14. So this, if you plot it, it is going to be displaying the confusion matrix. So for group A, what we see the confusion matrix component of group A and group B, we can see that high true positive rate, and there are some false positive, means model has given the outcome which was incorrect, incorrectly classified cat, but it was not a cat. So now once we have estimated it, then already see that what confusion metric look like, then we can calculate fairness performance metric like positive rate, then it is going to return Y prediction, then true positive rate of the data. So small program has been written. It is for visualization purpose. The lecture 2, how are you going to follow it? That by looking at it. Later, we will do the hands-on where you are going to write the code and run the program. So after I cover lecture 2, lecture 3, 4, 5, 6, 7, then we will have hands-on for whatever we learn in this course, and we will do it by taking some example data set and doing some hands-on on some case studies. So you can see here the true positive rate, and other metric which we have calculated for this particular data set has been given here. Now, if you want to calculate the key fairness metric, okay. So the key fairness metric in our lecture, we have studied many more, but here what we are seeing is statistical parity difference, disparate impact, and equal opportunity difference, and predictive parity difference, PPD. So what they are, you can follow my lecture, what we have done in this. Here we are doing from the programming way, we are trying to find how they appear and how they look like. So you can see the statistical parity difference, what has been done, positive rate of class A minus positive rate of class B. So that has been calculated, and the value you see 0.99. Similarly, the disparate impact is positive rate of class B divided by positive rate of class A. Now, similarly, so the equal opportunity difference, which is true positive rate minus true positive rate of B, A and minus B. Similarly, PPD is predictive parity difference, which is positive predictive value of A minus positive predicted value of P. So with this, we calculated this 4 fairness metric. SPD is 0.099, then disparate impact is 0.89, and EOD is 0.14. You can see this fairness metrics varies a lot. And we can see that the fairness metric for this very simple data set are not, they're indicating different thing. They are not indicating one metric is going to say it is fair, the other is may say the contrary concept. Now, if you want to compare the visual comparison with this group wise, means group A and group B quantity, then what will we see that positive rate of group A is higher than group B, and true positive rate of group A is higher than group B. And similarly, positive predictive value of group A is slightly higher than. So this is an example data I have taken where the condition is like this. Now, if we want to interpret what is this means. So from the SPD value, what we saw before is 0.099, the SPD value is acceptable because positive outcome rates are not differing dramatically. Means the value is small, so statistical SPD value is acceptable. But if we take the EOD value, it is showing a big gap. EOD value is showing a big gap. If you see, the EOD value is 0.140. So, which is showing the large gap. What does it mean that because it is showing the gap, this model is going to miss more truly qualified individuals from group B. Means it is going to miss the true positive or truly qualified individual from group B. So this model is going to be unfair towards group B for the qualified candidate. Similarly, PPD, if you see, PPD is similar because model predict the positive and the predictions are similarly reliable across the group. So positive predictions are reliable across the group. So this is exactly why the different fairness metrics can lead to a different conclusion. So now what to think about? You can see the EOD looks acceptable while SPD look acceptable, but EOD look not acceptable because there is a big differences there between them. If you see the, sorry, cursor is moving. So you can see the SPD is 0.578 for A, but 0.479 for B. So not much difference, but there is a EOD showing noticeable gap. Okay. Now, if we see try to see the fairness metric in one bar chart, we can see the SPD for this 4 metric is showing a small value, so which is acceptable. EOD is showing large value and PPD is showing small value, so which is acceptable, but EOD is large, and similarly DI is also large, so which is also showing that for disparate impact it has a bigger fairness, so has bigger biasness as per the DI metric, disparate impact metric. So now let's also see how the threshold can change the decision. If we change the threshold, how the fairness values or fairness behavior change across. So I have taken some example. You can see if I put a threshold 0.45, then SPD and DI and PPD calculated when 0.6, then also they are calculated. And by comparing with different threshold, what we see that when we put a threshold to determine this true positive and false positive and those criteria, we can see that SPD with threshold of 0.54 is rising. But for other threshold, it is lesser. Similarly, the EOD is rising up to 0.5 threshold, and then after that it is falling. So what threshold has been chosen to indicate the decision boundary that can give you the different outcome. So decision threshold can have an impact. Okay. So what we learned that a model can look fair from one metric if you are just choosing one metric, but the same model can look unfair if we take the another metric. Now, this fairnessness, why? Because different metric in our lecture also we know that different metric measure different thing, like SPD try to say whether equal positive outcome is being maintained for the different groups, while disparate impact is going to say whether relative positive outcome rates are in the fairness level, while EOD is going to ask whether truly qualified people are identified equally across. So means if we are doing the AI-based hiring thing, so group A and group B, if you have 8 truly qualified candidate in group A, and you have 8 truly qualified candidate in group B, so if our EOD metric is smaller, then we can say that this model is going to perform okay for candidate who are truly qualified, but it doesn't say that it is going to perform okay for candidate who are not qualified. So you can see that the metrics have a different outcome or different targeted things it measures or different fairness it measures. So in essence, there is no single universal fairness metric. So if anyone say that what metric, what fairness, so you have to say depend on what is my application domain and what is the priority we have defined for this AI system, and also which type of harm we want to reduce, whether we want to reduce the equally qualified candidate should be given chosen correctly, or we should be want to give equal opportunity to both the group. So you have to know what we want to target, and depending on that, those kind of fairness metric has to be evaluated. And in the next lecture we will see what are the mitigation and other kind of things. So I hope you enjoyed this hands-on, or I will say visual walkthrough of lecture 2, that how visually the data set is looking higher, better, and also the different metric values, how can change. Even for the same data, the model can give different kind of outcome for different metric. So I hope you enjoyed it, and see you in the next class.